every Clojure talk ever. Hi, I'm Alex Engelberg. I didn't really rehearse my slides that much. I'm basically going to stand at the podium without moving around much. I'm probably just going to read all the words directly off the slide verbatim. Chances are that you can read faster than I can talk, in which case when you finish reading the end of this sentence, there'll be an awkward moment where even though you're done reading it, I'm still not done saying it. So you just have to sit there and wait for me to finish talking before we can go on to the next bullet point. Also, fun fact about me, I like pizza.
This slide is about me, but this talk isn't about me, it's about you. It's about us. It's about community. It's about the 80% of you that are jammed into the equivalent of a cheap budget airline middle seat. It's about building. It's about us. It's about me saying nothing of substance, but saying it in a way that sounds like maybe there is. You knew this was coming, so let's get it over with. Profound. You take the dictionary and you split it apart and then you're done. It's that simple. So let's do just that. Pro, from the Latin, professional. This talk is going to be very professional. And found. We found all the content in your talks. Thanks. So who are we? We are Random Corp, and our mission is to change the world. How do we do it? We leverage blockchain technology to power IoT solutions. In the cloud. Using machine learning. At scale. To optimize cryptocurrency ICOs with Kubernetes. Everybody in this room should work for Random Corp. We're amazing. We've got it all figured out, and we have some very unique perks. Alex, why don't you tell them about them?
Weekly invigorating leadership speeches. Half-finished research projects to put on your resume.
You're welcome.
Late paychecks.
That happened once. One time, Alex.
Triplet programming?
Pair programming is like super last year.
So if there's one thing I want you to take away from this talk, it's that software is hard.
It's very hard.
And one thing that we didn't really consider when we were trying to build this vision is just how hard software is, you know? And my job is to kind of walk you through what we encountered and teach you some lessons along the way. And I want to show you this architecture diagram that we came up with. We have a front-end server, and we have a cluster of front-end servers, and we figured we need to sort of balance the load. So we added a load balancer, and this got us another sort of 6 months or so. Then we realized the front-end server was falling over, so memcached. The memcached also got us sort of another 3 months of leeway before more traffic was coming in. And then the memcache started running out of memory, so we were like, another memcached.
That's to me.
We heard a lot of good things about message queues. And we really wanted to include a message queue in our architecture. We couldn't choose between the sort of top competitors, Kafka and RabbitMQ, so we just include both of them. And we just let them kind of chase each other around a little bit. So that's the front-end server, and then we get to the back-end server. And this is where it gets interesting, because this is where you have to choose your database. And we stepped back and we said, what problem are we trying to solve? And we decided we needed a database that was that had high read throughput, it was version controlled, and it was highly available. And we're at a Clojure conference, so you can probably guess what technology we went with. We ended up going with Google Sheets. And
hey, it's like Datomic, but cheaper.
So we had the front-end server, the back-end server. We were like, what's next? A back-end server.
3-tier architecture.
So we went on like this, and we made a lot of architectural decisions. And before we knew it, it looked like this. And we were just, I think this diagram does a good job of of really illustrating that the decisions that you make early on in your company can really kind of bite you later in your company's life if you really don't really take the time to really think through those architectural decisions. So hopefully this kind of teaches you all a lesson on like kind of how you should really build your architecture. So we ran into some challenges. And at Random Corp, we consider challenges to be opportunities. They're opportunities to give back our lessons to the community and let you avoid making the same mistakes again. And when we wanted to transmit those lessons back to you, we turned to the only form of communication that really makes sense for these, which is angsty medium thought pieces. The first thing we did was we used Slack for revision control.
Hey, if it's more than 10,000 messages old, you probably don't need it anymore.
Our continuous integration was actually just a cron job on my laptop.
Hey, if I give my source code to the cloud, what if they don't give it back?
Finally, type systems. Ugh. That's my nuanced hot take. I'm just going to leave it at that. So we had these challenges, and if you look at these problems that our company was having, if you can kind of distill that down to one thing we needed to change in our company, I think it was obvious. We needed to choose a new programming language.
Obvious. Now, choosing a new language is a big decision, right? This can be make or break for your company, and we wanted to be thoughtful about it. You've seen evidence of our thoughtfulness already. We wanted to follow a scientific process where we really evaluated the pros and cons and understood the elements of the language that were going to best fit Random Corp and our goals. So of course we turned to the same tool many of you have in the past, Wheel of Hacker News. And we spun the wheel and it led us down a path. Just so happened we started with Go, and wasn't bad. Things were going pretty well. But our code base started to grow, and yet the compiler was still super fast, and we couldn't really trust the compiler was doing a good job when it was that fast. So, of course, we moved on. Ruby came up next, and unfortunately, after some brief research, it was discovered that Ruby's actually a color, not a programming language, so that was right out. Then Scala. We thought, should we use Scala? Maybe. Maybe not. And so we moved on, we built more Scala, and unfortunately this is what we looked like while we were waiting for it to compile. So that didn't work either. And we just kept going down the list, and there were so many possibilities and so many languages to try, and we tried all of these, and it was such an arduous process to go through and to try and understand the pros and the cons and to pluck from this list and figure out which language really works for us, which language is really going to power our next generation Random Corp platform. But we found problems in each of these, and the biggest problem was that half of these languages don't exist. We just made them up. That didn't help. Mm-hmm. So we needed a different approach. And we've learned from many of you that when you're trying to make a decision that involves Clojure, sometimes going to Wikipedia and other places isn't necessarily the best way to do it. So instead, we went to our local library. And we walked directly into the section with the oldest books we could find. You have to walk through a dust cloud to get there. And we plucked from the shelf, just by happenstance, some old book. And some old book was incredibly powerful and inspirational. It was written by very smart people, and they use very big words. To be honest, we didn't really understand a word of it. And it was definitely not at all about Clojure, and yet, it was, because we say it was. And it became clear that Clojure's the language for us. Off we went.
So it's time to learn Clojure. We were coming from a Java architecture, and when we started learning Clojure, we noticed a bunch of stark differences, some good, some bad. And I want to show you kind of the things that we ran into. First, we'll start with the good. And first thing is, error messages. Java error messages, you're going to get a lot of these if you write a server in Java. You're just going to see these all over the place. Null pointer exception, what does that mean? Stack traces, where did these come from? But then we turned to Clojure, and we noticed a stark improvement. Boom.
Yeah.
2.5 hours later, I was able to find what was wrong in my form. Yeah, I know Clojure 110 is going to fix this, but just like let me have this one. Let's talk about state. In Java, we love encapsulation. And what encapsulation means is you have your class and you have private variables. And you put your state in those variables and don't let anyone else touch them except through your getters and setters and your constructors. And this is encapsulation, and we came to know and love this when we were working in Java. Then we switched to Clojure, and we were like, okay, apparently it's like more elegant or better or decomplected if we switch to records or something, and like everything's better now. But I was very unsatisfied with this seemingly clean approach, because where did my encapsulation go? I wanted my encapsulation back. And that's clearly the best solution, because it's my opinion. But Clojure is extensible. So when I have an opinion, I can just change the language to my liking. And I'm a problem solver. So I put together a solution to this problem. So I'd like to show you what I came up with, and I think it's really awesome. I brought back the encapsulation. We have our getters and setters back. And then it came time to put in the state, and we were like, you know, Clojure is usually immutable variables, right? But they have atoms, so let's just use them. Yeah, there's that @ sign signaling to me something's wrong, but I just kind of went with it, and I think this is clearly the best way to use state, and I hope you agree. Let's talk about macros. If there's one thing I want you to take away from this talk, it's that macros run at compile time, which means, like, that's the obvious conclusion to draw, is that there are no downsides. Like, at all. I promise. Which means you should use as many macros as possible. Let's talk about threading macros in particular. Now, I think these are a real game changer, because you can take a data structure, you can apply a lot of operations to the same data structure. And it looks nice and iterative. It's really easy to read, and I really like these a lot. And you probably do too, but we all sort of run into this problem with threading macros that eventually we have a lot of different operations that we want to apply that don't quite fit into the same mold of the same threading macro. So for example, you know, we have conj, and that takes the collection as the first argument. We have mapv, that takes the collection as the last argument. And you know, so we ended up having the thread first, thread last, we had the as arrow and the conj arrow. And I think this looks really ugly, because we have to compose all these macros together. It's just gross. It would be nice if we had one macro that could combine all these together. And I'm a problem solver, and I can extend this language. So I did. I have the thread first, thread last, backwards, question mark, as arrow, conj arrow, bang. And this is amazing. It's the most elegant way to solve this problem, because it's a single macro that combines all these different macros as behavior. And
so much better. Big improvement.
It's so much better already. And we introduced this in our code base, and it was an absolute game changer instantly. And I'm so sold on this idea, I've actually made a repo. You can check it out. This actually exists. If you want to go check this out, just go to thread first, thread last, backwards, question mark, as arrow, conj arrow, bang. It's pretty awesome. This is the bread and butter of our code base, and I hope you get some use out of it.
You guys can go there right now on your mobile phones. We're happy to wait.
Yeah.
Should just take you a few minutes to tap that in there.
Yeah, give it a star.
Don't mess up a character.
Yeah.
Yeah.
Build tools. When we got to build tools, we determined the options available to us were line again. So I'd like to move on. The REPL. If there's one thing I want you to take away from this talk, it's how amazing the REPL is. We're Clojureans. We love our REPLs. And it's the most instantaneous way to run your code. And if you've written any other Clojure or any other non-Clojure language, you've probably had to worry about, like, how much time is it going to take before when I write my code and when I get to see if it works. But when you have your REPL available to you, you can instantaneously send your code to the REPL, and it's the speediest experience for development. I could just keep talking about this, but I just want to show you. We have a demo prepared. It's going to go great.
Please, demo gods, shine upon us.
So if I just type line REPL, and this is going to be instantaneous.
It's about immediate feedback. It's about speed.
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 Once this loads, it's just going to be the fastest experience ever. We just have to wait a few seconds for this to load. Okay, it's making progress. Yeah, this is going to take a little while. It's fine. This happens a lot. I'm just going to go back, and we'll come back to this.
So we've noticed a lot of you, as you go through your Clojure journey, you start off a little like we did, right? Maybe translating from the thing you knew to the thing that's new. But there's that moment in all of our journey where we get it. Clojure makes sense. We find the essence of Clojure. I think everybody sort of comes to the same realization.
Yeah.
And so we want to share that realization with you. But first, I want to talk about where we started. 3%. We were very proud of this. 3% was the reduction in overall lines of code when we translated from Java to Clojure.
Thank you.
3%.
Thank you.
Powerful, transformative effect. And yet, we talked to people. We watched your talks, and it seemed like maybe we were missing something. Some people thought we could do even better. It seemed unimaginable. But then we got it. We figured it out. They didn't. We figured it out, and because it's so important, this was an epiphany, I'm going to look everybody in the eye, walk to the edge of the stage, and say very slowly, this epiphany we all reach, it's just data. I don't know if everybody got it, so I'm going to continue my walk across the stage, and I'll just say it again from here. Move the slides. It's just data. I'm saying it really slowly so you know it's important, but I feel like I need to say it one more time over here. It's just data. We all get it at some point. They still don't get it. Okay, I'm going to do it one more time, but I'm just going to say the last word, and I'm going to say it very slowly so you know that's the important one. Data. That's what Clojure's about. That's the essence of Clojure. That's what we were missing. And it's Clojure, so it's not just data,
Yeah.
It's extensible data. Extensible, that word is very, very important when you're thinking about your data. Mm-hmm. You know, maps, those things we exalt, those things that should not be denigrated. So let's explore, because we can understand this essence of Clojure, we can understand that it's just data, but how do you actually take advantage of this epiphany that we found? Like, how do you just use data in a Clojure program? It's a little confusing. So we looked to the web to kind of understand. We said, this is important for us to get right, so we want to research it, as anybody does. And of course, we don't just want data, we want extensible data. So extensible data goes into Google, and what comes out? The answer to all of our problems. Literally the first result. We were very happy. We didn't have to go hunting too far. So we clicked right through, learned about XML, and found that that was indeed just data. It was exactly what we were looking for. So we took that big mess of atomy mishmash from before. We knew that was bad now. That's not how you do Clojure. Yeah. And we turned it into this. And I think we can all agree that this is a beautiful transformation of that otherwise ugly thing. This is just data, pure data. This is the Clojure way, we all agree. Mm-hmm. And let me just highlight this one beautiful, compact section of just data. And if you look a little closer, you can see it. The data. The data is right there. It's just data. It's beautiful. But unfortunately, we quickly found that even though we had this beautiful just data representation as extensible data, we still had to use it in our program, right? We still got to get this into Clojure. Fortunately, this is very easy. Clojure is an extensible language, and this little tiny code snippet is all we need to be able to leverage this beautiful, pure, extensible data in the runtime Clojure representation of extensible data. I'm not really sure what to call that, but that's sort of where it ends. If you look closer, you can see this very compact piece of Clojure code that just parses it. One of the great things about truly extensible data is that everything is a string. I think that's what extensible means. Which gives you the opportunity to write a lot of coercion functions. Those are my favorite functions to write. I'm assuming you all agree. And so what we were left with here was sort of a beautiful Clojure in-memory representation of extensible data. We really need a name for that. I'm not sure what to call that. And yet something was missing. We lost something. We had this kind of mishmash of atoms, and we knew that wasn't the Clojure way. But it had this beautiful property that we were missing.
I want my encapsulation.
That's the one. That's the one. Fortunately, Clojure's here to help us bring it back. So we wrote this beautiful function to encapsulate data. And encapsulation is all about limiting people from seeing things that they're not supposed to, because that's dangerous. We all know that as Clojure programmers. So here you can see this beautiful and simple function that simply shallow walks through our Clojure in-memory representation of extensible data. Still need a better name for that. And it tests against this concept we invented called a visibility map. It's a beautiful concept. And if you don't have access to see something, we just replace it with a value. Obviously, you're expecting something back. We don't want to throw an exception, but we need something to put in there. And so let me just highlight for you, we found the perfect thing to pop right into that slot that you were expecting to get something back. So this was really great, and we were excited to have this very general purpose encapsulate function, but then how do you use it? So let's walk through. So first, as a starting point, I want you to focus on the visibility map itself. Now, unfortunately, this visibility map has a problem. We were lazy, and we wrote it directly in the Clojure representation of extensible data, as opposed to data itself. So we're working on that, and once we get this visibility map into proper extensible data into an XML file, we will open source it. You're welcome. But once you have this visibility map, how do you use it? It's so easy. You just pass it through to your encapsulate function, and then encapsulate uses it, and what comes out the other end? Nothing.
Nothing?
No, like, not nothing, nothing. Nothing.
Nothing?
Like, nothing.
Nothing.
Yeah. I think you get it.
Okay.
And I'm really proud to announce that after going through this process of porting our code base the Clojure way to using proper extensible data at the cost of just a few 100,000 lines of XML, we were able to achieve a 4% line of code reduction from our original Java code base, and we're very proud of that. Very proud.
Thank you very much. Okay.
Thank you.
This is a Clojure talk. So I have to give you a table of things that are, I'm going to show you all the really dumb, complex things that you have to deal with, and then show you all the simple, awesome things that we get because we're on Clojure. Syntax. Data. Inheritance. A box of corgi puppies.
Stuff.
Monday mornings. Friday evenings. Tripping over a pile of Lime bikes outside. That dance that Snoopy does. A tech booth in the hallway that's giving out cool t-shirts, but ran out of your size. A perfectly popped bag of popcorn. The dark void that resides within your sad, sad soul. The REPL.
Oh, wait, we forgot about our REPL.
Yeah, that reminds me.
Let's go back.
Yeah, let's go back.
Should be ready now. Oh.
Okay, this is fine. This happens a lot.
Yeah, that's normal, I think. Actually, try it, like, sometimes if you hit enter, it'll just...
Oh, there we go. Okay.
Thank you, demo gods.
Okay.
That was a close one.
Okay, so we're in our REPL, and I can actually show you how amazing it is. And I want to tell you a little something about Clojure called Clojure Core Async. This is really interesting because it lets you write your concurrent programs. And I'll just kind of show you, now that we have the REPL up, I have Clojure Async. I should have Clojure Core Async here. And then I'll do this, and then...
Alex, I think you forgot to include the library.
I know.
dependency. I think maybe we're going to have to give up on this.
Okay, fine. Yeah,
All right, let's move on.
Okay.
So as I said earlier, this isn't about Alex and I or Random Corp. This is about us as a broader community. And we need to grow that community for Clojure to continue to be fruitful and provide the benefits for all these other companies that it's provided for Random Corp. One challenge. Clojure is still a smaller language, and we don't necessarily have a huge marketing budget. We thought we could help. And so we worked with a team of professionals and created what we think is a powerful and compelling advertisement that's going to bring more people to the Clojure community. And we're excited to share it with you today.
Do you use boring programming languages?
Why does it have to be so enterprisey?
Are static types weighing you down?
How am I going to get promoted if my code doesn't compile?
Do people recognize the stickers on your laptop?
I'm so mainstream.
Boy, do we have the product for you. Introducing Clojure.
Clojure is a list that runs on the JVM.
Clojure.
Immutable persistent data structures everywhere.
There's also a transpiler from Clojure to JavaScript.
Clojure script.
First-class support for software transactional memory.
Reps.
Actually, nobody really uses reps.
Atoms.
It's easy.
It's easy.
No, I think you mean simple.
Simple. Just listen to some of our satisfied customers.
When I choose my coffee, I need to make sure there aren't that many other people drinking it. So Clojure fits my lifestyle perfectly.
Hipster-driven development.
With Clojure, I enjoy using Emacs.
Emacs is now tolerable.
So it's critically important when you're building software to take into account not only the benefits, but also the trade-offs. And an important part of Clojure development is analyzing the problem and considering more than one choice.
All benefits, no trade-offs.
Everything makes so much more sense when you realize it's just data.
It's just data.
It's not code, it's data.
No code, only data.
It's just data.
It's better to have 100 functions operate on one data structure than have 10 functions operate on 10 data structures.
So what are you waiting for? Become a Clojurian today.
Some restrictions apply. See store for details. Side effects may include side effects.
You're welcome.
We have nothing more to give, and we're not taking questions. Thank you. I hope you all enjoyed the conj.